Welcome, everyone. So thank you very much for attending. And the topic of this roundtable of the discussion is: in which direction is social robotics for education developing? When comparing the use of social robots in education with other branches of robotics research, it becomes apparent that the range of their application is limited only to some specific cases. No? As we can see here, they are mostly used for children with special needs in preschool or primary school and for STEAM school education. The majority of the robots, even so they are called social mediator, their role is usually limited to displaying specific content relevant to the educational objective of the class and exhibit limited behaviors in order to provide motivational support in one form or the other. So basically the main areas we see robots for education at the moment is in robot-assisted therapy. Here specifically prominent is the field of robots for children with autism spectrum disorder and robots for education, and here specifically in for different applications in STEAM education, but not necessarily as social mediators. And even if they are called social mediators, they have limited social functions. So the question is why we have these limitations. The goal of social robotics research for education is that students and teachers can communicate and interact successfully with the robots in complex social environments. And this interaction would need to be flexible and pleasant for the students and for the teachers in order to be engaged in these exchanges. And the robots should reinforce the particular nature of the learning process and the construction of new knowledge in the students. Now, we have to acknowledge that we are still facing some severe changes in social robotics. So we still have inappropriate feedback from the robot due to limitations in sensor technology. We have perception issues. The robot would need to identify the human that speaks to the who speaks to the robot. It would be great if the robot could understand the goals and intentions of that human and then react accordingly. And the communication, in order to be successful, would need to be multimodal, and all the aspects, and this is the most important part, all the aspects should be synchronized. So the behavior within the robot should be synchronized, the different movements the robot is doing, but also the behavior between, or the reaction of the robot towards the human should be synchronized with the human behavior. So these are still issues that we are facing specifically in classroom scenarios. So we would like to answer or discuss, discuss in this roundtable could look, for example, like, well, AI has advanced quite a bit in the last 5 years. So why did the application of social robots for education has not advanced at the same pace? Is this due to unsolved technological issues, or does it has to do with theoretical grounding in didactics of this technology? Are we having shortcomings in the design of our agents, of our robots? Or could these issues be solved through changes in political administration for education? These are just some examples to start the discussion, or within the discussion to move forward. We are very happy to have quite an international analyst. Very welcome to Professor Gentiane Venture. She is a professor at the University of and has academia in Japan for more than 15 years. Welcome, Professor David Scaradozzi from University of Università Politecnica delle Marche in Ancona in Italy. Welcome, Professor Ioana Ocnarescu from the STRATE School of Design in Paris, and welcome Professor Luisa Damiano from IULM University Milano in Italy. We were thinking to start the discussion with a little presentation of each panelist, 5 to 10 minutes about their work, just give an overview of their work, then have an open discussion about some of the questions we posted, and then come up with the synthesis of the results of our discussion at the end of this roundtable. So without further ado, I would give the I would give the panel to stage to Professor Venture, and then let's follow in that order. The Professor Scaradozzi, Professor Ocnarescu, and Professor Damiano after that. So thank you very much, and I will stop sharing. So
as soon as I get the sharing ability, I will share my screen with you. In the meantime, I would like to thank you for inviting me today to this roundtable. I'm very, very happy to be there, to meet new people, to see familiar faces as well. And if I could share my screen, I would be very happy.
It's good to host, maybe change the permissions. Who has the possibility to change this?
Nicolò, can you share the presenter?
It should be Gentiane Venture.
Okay, Luisa now is the presenter.
No.
Venture. Nicolò, can you give the presenter role to Venture, please? Okay.
Ah, good. Thank you very much.
All right.
Okay, that's perfect. Okay. So I'm thinking that you are seeing my screen at the moment.
Yes, we can.
Yeah.
Okay, because I can't. So I don't know what you're seeing. Anyway, so yeah, tonight today I wanted to talk about like the work that we're doing towards living with robots, and so to start with, I just wanted to introduce you.
I'm sorry to interrupt, but
yes.
I see the screen only very little.
Oh damn. Okay, let me make it big then. Is it better?
Yes. Now it's better.
Perfect now.
Okay. Okay, great. So I wanted to talk to you briefly about the activities that we're doing. So my lab is a lab at the Tokyo University of Agriculture and Technology in Japan, where we conduct interdisciplinary research with many researchers and many types of robots. And we have basically mainly three big activities. And in these activities, we do what we call human motion science, sensible control, and human and robot shared life. And the idea of our work is to try to understand human behaviors and human affective movements, and to use this to generate and create intelligent robot controls that can understand these behaviors and these affects, and also generate movements that could be effective as well. And then to use all of this technology in real environments, so basically in the wild, where robots and humans are sharing the same space, whether it's at school or it's at home or it's in the workplace. So for human motion science, the component in human motion science, we analyze the human body movements, we analyze the dynamics, the kinematics. We also use this in virtual environments, in real environments, and with robots. For the sensible control, we try to generate movements that are taking into account what the robot can perceive around itself. So whether it's humans or the environment at large, so it could be also perceiving the atmosphere in the room or in the place the system is. For example, the luminosity, the level of sound, the humidity, the temperature, and take this into account to try to also understand what humans are feeling. For example, if you are in a very noisy, very, very bright and very, very hot environment, probably people will be irritated. And so that could explain some of their behavior. So we're trying to take all of this into account. And then we're trying also to create systems that can generate autonomously expressive movements so that we don't have to use animation techniques anymore, but we can very simply recreate motion that can express something so that the robot perform a movement or do a task or do something, and at the same time can express what it senses. So for example, it can express its own perception of the environment. It can express its own perception of its own sensing modalities. For example, the robot is going to be overheated because there's too much load on it, or the battery is going to die, or this kind of thing. And then it takes into account what the humans are also doing and feeling. And then we take all this together and we put it into what we call human-robot shared life. So we put the robots at school, we put the robots in public places, and we put the robots at home. And usually our scenario are such that there is no scenario. So that people that encounter the robots can do whatever they want with the robot. So they can play with it, they can interact with it, they can ignore it. But the robot always does something in reaction to these behaviors. And so, for example, when we bring the robot into schools, we are totally like leaving the kids up to their own judgment, whether they want to touch it or ignore it or want to dance with it. So we have some children that are like very fond in touching the robot, dancing with it, holding hands, and some that are just like not very much interested. And in public spaces, it's the same. The robot, exactly what Hagen was saying before, the robot can sense what the person in front of it is doing and feeling and react according to that. So basically, the robot takes into account engagement, proximity, like if the person is pleased or not and interested, and what kind of, for example, objects they are interested in, and then can deliver these kind of objects. So for this roundtable today, there are a number of questions that we try to answer at large that I would like eventually to talk to with tonight today. Is like what is it that makes a robot a robot? Like what is different between the human-robot interactions and the human-human interactions? And how can we really emphasize this aspect that a robot is a robot and it's not the human? So we have to, in my opinion, try to create robots' behavior and robots' ontologies that are different than those of humans. The other question that...
Sorry to interrupt you. I was communicating with Ioana. We both cannot see you. So we see only partially your slides. We see a big gray square.
Oh, is it better?
This is fantastic. Yes, I see. I hope. Okay. A second, I asked to Ioana. Ioana, you see it? Yes, cool. Okay, sorry. Okay. Sorry.
I apologize for that. So the second question that we are asking ourselves is how, like, actually, are robots really useful? And if they are, how can they really be useful? And how can we do that? As a roboticist, I'm always asking myself this question. It's like all these robots that we're developing, are they really going to be useful? And what can we do, or how can we make them useful for real? And then the last questions that for me is really a key to my research is what does it mean to live with robots, and how robots are changing our society and are changing the way we're living, and what is at stake then here. So I would like to thank you very much for your attention, and I'm looking forward to the discussion.
Thank you very much. Very interesting questions and very interesting work. Thank you for sharing this with us.
So who is next?
Next would be Professor Scaradozzi.
Okay. Nicola, can you please give me the presenter role? Nicola. Okay, so now I just, okay, I put in the screen simple slides just to introduce myself. I am an assistant professor of Università Politecnica delle Marche. I am a control and automation engineer. In our labs, okay, this is the name in Italian, Laboratorio di Modellistica, Analisi e Controllo dei Sistemi Dinamici. We study identification and control techniques for obtain model of artificial or natural systems in general. But in particular, our know-how are in educational robotics and marine robotics. It's strange, apparently it's strange, but we have an historical cooperation with our Navy, our biologists and our ecologists. So part of our know-how came from marine robotics. But also we started more than 15 years ago to introduce robotics as a curricular subject since the primary school. So another field where we are working is developing new tools and new learning schedule to introduce robotics and to create new curricula in primary school in particular, but also on secondary schools. So our cooperation are from more than Europe country. We cooperate with different laboratories all around the world. Within European projects, national projects, but also with international projects. In particular, sorry, I have to remove this. In particular, our competencies and skills are on development of robotics tools for lesson plans, in particular educational kits, and also on rapid prototyping of mechatronic parts of a robot. Our aims are mainly incorporating robotics in school curriculum since the early stage of education, introducing children to STREM or E-STREM, adding E because thank you to our experience on marine environment, we have a lot of projects to introduce robotics, but also marine environment aware and to introduce children to consider both robots and the environment where the robot have to interact. In particular, now we are starting working on ethical robotics, for example, in order to introduce ethics at the design time. This is important in primary school, in secondary school, but at the higher education, where we starting a number of projects now. Also, in the last 5 years, we started working on assessment of learning experiences. And this is why I prepared for this morning a slide that I wanted to share with you. In this slide, in this page, we have a typical situation where kids interact with a robot. We know that in education with robots, or when we have a robot in an education situation, we have kids or students that work not with a closed product, but with a set of actuators, sensors, and many components. At the same level, we know that these components can become sensors for us. So if we think that we introduce technology in the classroom or outside the classroom, we can have talking technology. So we can ask directly to the technology to refer us how the kids can interact or interact with the technology. And this is a lot of information that we can use to model the interaction. And these models can be used to have a feedback in the product improvement, but also in better understand what happened during the interaction, how the robot can be used as media to communicate something to our kids. This is our main idea around our research. So we started 5 years ago to modify some products around or in the market and modify them in the coding or in the internal sensor in order to let them able to communicate in a cloud what are happening during the interaction. And we start creating a machine learning supervisor able to understand what happened during the interaction. So this is a general view of our actual system, where we have a number of schools that work normally, where the teacher or the teachers ask to our student to create a solution with educational kits in a normal way, like they can do in a normal lesson of educational robotics. But in the meantime, we collect a lot of data that our machine learning procedures are able to clustering and to refine, to obtain a possible way to model the situation. In the last period, we are working on create some performance indexes of this technology in order to understand better what type of machine learning procedures can be used in the educational system or in the educational environment. So mainly this is our research activity, and what I can put in the table, if you ask me as engineer to put some points, first of all, I think that we need to better identify what is the product in education or in an entertainment market, for example. So what is the product? The final product will be robots, tech devices, or the learning outcome, for example. Because it's different if we are thinking that the new products are robots, or we are thinking that the new product will be the learning outcomes during inside or outside school experiences, for example. Also, if we go only to the robot or to the device, I think that we need to improve our design methodology, because we need to take care of the last decades of innovation in identification and control, because we work a lot in identification and control strategy, but we do not find, we haven't this innovation or this new theory, these new theories in the education market. Also, for example, information and technology innovation. I think we do not have in the edutainment market what we have, for example, in the automotive market. And also, I think that in this market or in this field, we have to introduce other modern concepts like cyber-physical systems, or, for example, digital twinning concept. If you think about automotive market, for example, we can see that in the automotive market, the company do not consider the product finished at the selling time, but they know that the cars can talk after the sale. In fact, today, during our journey, when we drive our car send a lot of information to the company that design our car. Because this is because 10 years ago, in the automotive market, they started to work on digital twin concept. So when they design a new car, at the time when they start to design the components, a single components, they create a digital virtual model of the components. And during the design phase, during the validation phase, and after, when the car is in a real road, they continue asking information and they improve the digital virtual model of the car. This concept is totally out of our robot or of the robot that now we use in the education. So I think that we have to improve, sure, we have to improve the product, we have to improve how we consider interaction between kids, students, and robots, but we also need to consider other aspects that is already or are already present in other markets. So more or less, these are some points that I want to put in the table.
Thank you very much. Very, very interesting for the discussion. Thank you for sharing your research with us. And if I could ask the host to give the presenting capability to Ioana.
Yes, perfect.
Okay, thank you.
Okay. So can you see the slides, the first slide? Yeah.
Yes.
And the second? Okay. Hello, everybody. So thank you to my colleagues for this presentation. I completely agree with what you said about what is the outcome of the design process. I will say it with my words. Is it making a robot, or is it making improving some kind of education experience? So actually, I love robots, but I love more humans. So I'm going to talk a little bit about the design point of view. I'm head of a design research department in a design school near Paris. And I'm working in the field of robotics for 7 years. For 7 years. Actually, my PhD was not in robotics. I did a PhD in design, interaction design, and I had the chance to arrive in a big national consortium here in France on social robotics on a project called Romeo, who is a big brother of NAO. So there, actually, I developed myself as a researcher in social robotics. And since then, it's kind of a virus because I'm still working on this field. And last year, we created with different academic partners and industrial partners. Also, Luisa and Gentiane are part of this big project called Robotics by Design Lab. You have the website here in my slides, a consortium on 4 years with 4 PhD students, starting 4 PhD in the same time in different fields. The idea is robotics by design. It's about how people and robots, what does it mean to the ecology of living together. And specifically today, I don't have any experience with education and robotics and education and social robotics. I usually work on socially assisted robotics. So I had this title at the beginning because I talked to Luisa about what do we learn from what is working on robots that don't work, because usually the robots that I'm working on don't really work, but however, this is something magical sometimes happening. So I'm going to talk about not the functional part, but more of the human part, on what means to have a social presence in a space shared with humans. So the title of this short presentation, very brief presentation, is from social robots, from objects to subjects, okay? And when this magic begins and when it ends. So this is a design school. I mean, right now we are locked down in France, but our design school is still turning because we have lots of things happening, people in the workshops. We are building products, services, experiences, or work with tangible stuff, but also intangible stuff. The design project is bigger than a representation. Design comes from 2 fields. You have the design as a purpose. Every design project has a purpose. We tend to say it's a big project, it's a big purpose. To this citation from a researcher that I admire, it's to at least maintain or improve the habitability of the world. So very huge concept. But also, so design, purpose, but also design in terms of representation, form, but also interaction and relationship, okay? So how come that in a design school we talked about robotics? It started a long time ago. In 2007, the head of the school at that time created a department called Interactive System and Objects, and he created the term robject, which is everyday object, like a little bit in Disney, in the Beauty and the Beast, where you have all these the magic cup, and all these daily life objects. You can imagine a bench, a sofa, a trash bin that come alive. So they are everyday objects fulfilling their purpose, being a trash, being a sofa, or a chair, but they have a new skill. They are intelligent. They relate to each other and they relate to us. So on this concept, lots of projects were created at Strat. Some of them I'm going to show you a picture in my next slide. We also participated, as I told you, in this big assistive robotic project called Romeo 2. It was a very interesting project. We learned a lot from it. And we worked on Nao, Romeo, of course, but also on Pepper. And then in 2019, we launched Robotics by Design Lab. So these are some pictures of the project that we worked on at Strat. So this is the project that I'll do, Romeo 2. Other projects are more related to this is a pizza yellow that you have underneath, and we were asked to redesign the robot, but finally we didn't redesign the robot because it was a complex. The robot was beautiful in what he has to do. So our client asked us to put a head on this robot. So we didn't really understand why, because this robot was about everything else. So redesign everything else except the robot. Okay. Here underneath you have Le Jardin des Amours, who are these three types of objects I told you about. It's a lamp, a bench, and here it's a trash bin. Then they play a role in a theater, and they are not really autonomous. They were moved using a Wizard of Oz technique. So we're really cheating a little bit. So I'm ashamed because I'm with people doing working with robots at work. So I'm sorry. Sometimes our robots don't work, but still these robots were moved, and we experienced lots of stuff in public places, like what it means for this lamp to come closer to a group of people who are crowded, what it creates in terms of dynamics. What does it mean if the lamp is following one person in a train station, how this person is feeling. So all these gaming parts, which are very interesting in terms of interacting with one person or a group, are also, I think, interesting knowledge to take into account when we talk about living, as Gentiane is talking, living with robots, okay? Also student projects like this one. Actually here also, like my colleague Gentiane, we were interested more in the user experience of a robotic arm, very basic in paper, and it manipulated with some water tubes and syringes, if you can see here. The idea is how the movement is also expressing something, and what user experience you can express with exactly the same machine, but moving it around, it's fulfilling different purposes. And I wanted to enter into detail on this specific experimentation that we did at the end of Romeo 2 project. It was an experimentation that took 24 weeks with 24 robots. We don't use actually 24 robots, we use 3 robots, but 8 weeks. So in order to have 24 people experiencing and living 1 week with Pepper. And I will not enter into details on the applications that we proposed. They were super basic, like the weather or the program of these persons. We are in a rehabilitation center, so people there have a quite tight schedule in doing lots of activities in order to regain their health. We followed these people during this 1 week. We put some cameras on, and we learned a lot about when these people forget about the robot and what's happening if the robot doesn't work for 1 day, for example. What does it mean if the robot doesn't connect to internet? So all these things that usually happen so much in our experimentation were for us very interesting experience to learn about the relationship we have with these things. Okay, so before entering and showing my conclusion on these experiences, I want to show you a little video. Let me see if it's working. So it is in French. I'm sorry. It is. We put also the subtitle in French, but I will translate. I just want you to see a little bit to understand what sometimes is going on the field. So yeah, tell me if you hear. It said
yes, we hear.
Hear, but we don't see.
Ah, okay, you hear, but you don't see. That means that I didn't, thank you for telling me. I didn't share all the screen. Let me come back to. So you can't see my YouTube, right?
Yeah.
You see my YouTube?
No.
No. Let's stop the. Ah, okay. So how can I share my screen again? stop sharing. Okay, I'm back with you here. So I will, yes, share all the screen. Now can you hear, can you see perfect?
Yes.
Okay, so once again, I'm putting it to full screen. So this is one of the patients talking to sometimes he's talking to the robot, but what is more interesting when she talks to other people about this robot or using the robot as something.
Oui. Là, on dirait vraiment des doigts qui on dirait.
So she thinks that he really has fingers. So look at how she touches the
Il fait
paper.
très vrai. Coucou, c'est moi. Bonjour, Pepper, c'est Maria.
Bonjour Maria, je ne vous avais pas vu aujourd'hui.
Avant de faire de ça, veux-tu me donner mon planning là, je me suis un peu plus peur. Sois sympa.
So she asks the planning.
Eh bien, mon petit Pepper, tu dois me prendre pour une andouille. Est-ce qu'il va pleuvoir?
Is it going to rain?
Non, à Bouffémont. Est-ce qu'il va pleuvoir à Bouffémont?
Oui, c'est probable.
Merci. Mais tu sais, on n'est pas ici les Moulineaux, on est à Bouffémont. Bouffémont, c'est ici où on est. Je te parle de Bouffémont. T'as compris? On est dans le Vardoise, pas ici les Moulineaux. Bien, tu sais. Faut t'arrêter maintenant de faire les gens qui arrivent ici, sinon tu vas avoir une sacrée.
So she's
Tu vas continuer.
so yes, I don't know if it's you can understand anything about what is happening, so I will cut it here. So just to let you know what is happening. So this patient was extremely, I mean, we had this patient who was the most interested in the robot the whole week. She was so for us she was a perfect participant, but I mean not all the participants were as tactile, as capable of projecting themselves with the life with the robot. But she did the whole week that, and she actually, when she would talk to somebody on the phone, she said that this robot is something that gets her out of the ordinary. Okay, it's something that she's doing something else, and she's forgetting a little bit about her treatment or about some kind of the difficulty and the loneliness that she has in her life. So some global, and this is not only about these patients, it's something that we had for all the patients. I'm going to go back to my presentation, some conclusion. So yeah, lots of them, and maybe also my colleagues could tell about that the face design, the hand, it's really appreciated. So even if the robot doesn't work, the fact that it is designed as it is, it's something very, very important. It's part of the experience. So lots of people talk, he's cute. I like his hand. So it's a he. It's a man. It's a boy. He's touching with his bead eye. The face is well drawn, beautiful eyes, lively look. Then these people participating into the studies are feeling pride and valued. So the fact that the robot sometimes recognize a person and tells the name of the person is something who is really seen as some kind of important for the person having the robot. They have a lot of patience. As you saw, the robot really doesn't understand Bouffémont. She's asking what the weather at Bouffémont. He doesn't really understand Bouffémont, so he's still talking about another town, Issy-les-Moulineaux, Issy-les-Moulineaux. But she doesn't care. I mean, she said it again, and then she let the robot say the weather at Issy-les-Moulineaux, and okay. So lots of perseverance, politeness, And these people also made lots of improvement, and this is the medical care, the personnel that told us, lots of improvement in language, because these people also do.
Ioana,
yes.
Sorry to interrupt, but could I ask you to wrap it up, because we are running.
I'm sorry.
We
Okay.
are out of time.
So this is this is my last slide actually. So the last thing, it's about the personalization of the robot versus an objectification of the robot, because sometimes it's a robot and it's a thing, it's a subject, and sometimes it's just a tablet on wheels. And this is very interesting. So because he used only because we have YouTube and internet on the tablet, and we forget that he can move or he can do anything else. So yes, it's these two roles also that we saw during the experimentation. So yeah, I will leave it to that. Thank you for your attention.
Thank you very much. Sorry about cutting you short, but since we only have until 3:30 and we still need some time for a discussion.
Yes, of course, no problem.
Okay, great. So if I could, thank you very much. And if I could ask the host to give the stage to Luisa.
Thank you very much. While I wait to have the possibility of sharing the screen, I would like to thank a lot the previous panelists, and I think that are, in my view, are convergent in a sense, the answer I would give to the different questions we raised. 1 second. So I think now you see my screen.
Yes.
Okay, great. And the question raised by Gentiane, what does it mean to live with robots? And also the question raised by David and that was supported also by Ioana, what we want to produce. I think in social robotics, what we want to produce and what it means to live with robots is to create a new form of social relationship. And I think this could be also the point on which we could articulate the use of social robotics in education. So I represent myself. I'm Luisa Damiano. I'm an associate professor of philosophy of science at the IULM University. And my domain is that of the philosophy of the sciences of the artificial, or the epistemology of the sciences of the artificial. And indeed, I would like to focus my short contribution to our roundtable today on the epistemological and theoretical aspects of current research in social robotics that, in my view, are limiting and may even obstacle the diffusion of social robots in general and social robots in education in particular. And to delineate these limits, it can be useful to refer to the disciplinary complex of reference of social robotics that I try to draw in this slide, in which I draw social robotics as an area of robotics that emerges with a sub-area in which I'm particularly interested, and is my subject of research since many years here, artificial empathy, the part of social robotics dedicated to build robots interacting through emotions with humans. Social robotics emerged at the interface, let's say, between two big well-established areas in contemporary robotics. On one side, HRI, so the area dedicated to the construction of robots capable of interacting with humans. And so HRI has an interest in social robotics as a subdivision of HRI dedicated to construct robots that are interacting with humans through social signals, including affective signals that are compatible with human social signals. And the other area is what I call here cognitive robotics, using this label to refer to all the scientific lines of robotics. That is, the lines of robotics like epigenetic robotics, developmental robotics, developmental affective robotics, that are building robots as models of cognitive processes. So cognitive robotics is interested in social robotics as for its robotic modeling of social and affective processes. So all these areas of robotics emerged in the context of the so-called embodiment turn in cognitive science and AI. So they share the growing interest in social and in affective interaction, typically of embodied cognitive science and AI, and they share the main thesis of this form of cognitive science and AI, that is a cognitive system is an embodied agent that through its body interacts with an environment that is also and primarily a social environment. And so the strong interest in social and affective interaction in the case of cognitive robotics is articulated around the thesis according to which to model natural cognitive system and processes through the method that is the understanding by building method, is to build and experimentally explore complete agents, embodied agents, that is robots that are interacting with an environment and that is also a social environment through their body, a body through which they learn about their social environment and through which they accomplish cognitive tasks that are also affective and social tasks. So the part of social robotics that is grounded in cognitive robotics and is often called internal social robotics, and we call also like this the subdivision of social robotics focusing on the emotional communication between humans and robots, artificial empathy, as it focuses on offering its robots cognitive architecture, so internal cognitive architectures, this is the idea, capable of recreating at least some aspects of the physiology of animal and human social affective cognition. We have many research lines engaged in doing that, and they converge currently in the idea that this goal as such is out of reach, and they optimistically located this task in the future. And on the other side, the strong interest in social and affective interaction of HRI, human-robot interaction, is articulated around the thesis that creating effective interactive robots, that is, robots that are capable of effectively interacting with humans, means to build robots that do not have complex cognitive architectures, but are socially evocative. So they have a realistic expression of social signals, meaning an expression of social signals that is modeled on human or animal expression of social signals. And through this realistic expression, they can trigger in the user an anthropomorphic reaction, that is an anthropomorphic projection on the robot. The user, stimulated by this realistic expression, can project on the robot a social presence or other human mental states, typical like emotions, human or animal, but mainly human emotions, belief, desires, and so on. So based on these strategies, this part of social robotics grounded more on the HRI side and often called external because focuses mainly on the expression of social and affective signals, built robots that from the point of view of cognitive architectures so display a very poor, simple cognitive architectures, but are very rich in expressivity of social and affective signals. And on this basis, they show to be successful as therapeutic and educational mediators. Both in the case they are minimally autonomous robots like the robot Paro that can react to the touch or to the voice of its users, or are completely operated by humans, like in the case of Caspar and many others therapeutic robots with the techniques that was referring to Ioana, the wizard of Oz. So coming to the epistemological exploration of the approach to sociability that is acting in the production of social robotics, I have to say that my exploration converges with analysis performed by specialists in sociology, for example, like Raya Jones, that is working now on social robotics, or other philosophers that are exploring social robotics at other levels, in ascribing to social robotics what we can call an individualist view of sociability, according to which sociability can be seen as a set of property that belong to the individual, to the human or animal individual, and that we can simulate in an individual robotic agents, or we can try ideally to transfer on an individual robotic agent. And the first of the theses I would like to propose to our discussion today is that this individualist view is creating some limits in social robotics, because on one side it forces cognitive robotics to try to reproduce animal and human physiology of sociability in robots that, in my view, is optimistically a task for the future. I think we will never be able to do that. But also it constrains human-robot interaction to the space of the mere imitation of individual social expression, generating extremely limited forms of human-robot social interaction and making so very difficult to establish human-robot dynamics that are interesting for the users and are, in this sense, can be long-term social dynamics with the user. And the second thesis I would like to propose to our roundtable today is that an alternative view that I call a relational view of sociability could better support the evolution of social robotics and artificial empathy, meaning with relational view of sociability, the idea that sociability is not a set of individual properties that we can transfer merely simulatively or fully in robots, but is the capability of an agent of participating to social and affective interaction that has to be considered as a plural capability because humans between them are different in expressing this capability, and we are different from animals, and we have to think that artificial agents have to be different from us. The idea of social robotics explicitly, fully expressing a relational approach is that of a social robotics that then refers to artificial social agents as agents that are able to participate to social dynamics with humans instead of possessing a list of individual social properties that we can ascribe to animals or to humans. And the social robotics whose research focus is directed not to reproduce or to simulate animal or human social cognition, but is directed to build for robots interactive mechanisms that are allowing them to participate to social affective dynamics with humans, defining these dynamics, according to a relational view, as dynamics that are leading the interactors, in our case the human and the robot, to coordinate their disposition to action towards cooperation. We hope this is the goal of social robotics, or to conflict in their different declinations. And the third thesis I would like to propose for the discussion, and I think that I'm allowed to do that also on the basis of the previous presentations, is that a relational turn, a shift towards a relational perspective of sociability is already there, is already happening, taking place in social robotics, and in particular in artificial empathy. I think that Gentiane's presentation was very clear about that, in which for example, there are research lines in artificial empathy that are not implementing emotion only expressively or only trying to model animal or human emotional systems in robots, but they're trying to create emotions as a mechanism of human-robot coordination that then can lead to the interactors, the human and the robot, to the co-definition of their disposition to act. And this is typical of a research line that is called the affective loop research line in artificial empathy, which is trying to build robots that at the same time have an expressive anthropomorphizing system, so they express emotion exploiting the strategies of anthropomorphization, but the other side is this expressive system is related to an internal emotional system to control the behavior of the robots that does not model animal or human system, but is invented for robots or is only vaguely inspired by natural emotional systems. And through these two levels of organization, the robot tries to coordinate its emotional expressivity, in this case, to that of the user, and to create, in this sense, some emotional dynamics or social dynamics. So it's a research line in which to create the artificial affectivity, the affectivity of the robots, and artificial affectivity means not to focus on the intra-individual space of the robotic agent, not to focus simply on the human not to put this affectivity completely in the eye of the human, but on the interaction between the robotic agents and the human agents. So I try to close very quickly. Why should we go, in my perspective, towards a relational view of sociability for the future of social robotics, artificial empathy, and in education? Because in this direction, to create human-robot social affective dynamics doesn't imply the need of recreating animal or human social emotional processes in robots, but can focus the research on the construction of specific mechanism of a human-robot social and affective coordination, which opens to the field many possible lines of development and will be the nascent history of our interaction, our social affective interaction with robots, to decide to select which platforms are doing that better, which are the mechanisms that can coordinate socially and affectively humans and robots better, to create the coordination to act. So what I'm thinking of is a pluralist approach to sociability in the future of social robotics and artificial empathy, similar to the one we have already with artificial intelligence. We talk about artificial intelligence when we talk about computers and robots, without thinking that the way of accomplishing tasks, cognitive tasks, is based on the same mechanism that are underlying our cognitive performances. And the same can happen in artificial sociality, in artificial empathy. We can build dynamics of social interaction between humans and robots that are share at the level of the coordination between human and robots some aspects of our social and affective phenomenology, the one we display when we interact with other humans or when we interact with animals, but that at the level of the mechanism is completely different. There could be a long discussion about the epistemology of synthetic models here to talk about this, but of course we don't have time, so I will try to give a take-home message from epistemology to the future of social robots in education that is related to the critical importance of the epistemological and the theoretical choices that too often are implicit and too often are neglected. The choices we make when we build these robots, social robots, or when we talk or discuss also at an ethical level on social robots, because different epistemological and theoretical views of sociabilities, of emotion, imply different robotic technology, different forms of interaction, different forms of acceptance, and also different ethical approaches to the social sustainability of the diffusion of this technology and different concrete implications on our social ecologies. So thank you for your attention. I hope I will have the chance of talking a bit later, maybe during the discussion about ethical aspects. Thank you very much.
Thank you very much. Thank you very much. Also for this very dense presentation and for all the new information. And I think we have enough material to start an interesting discussion concerning some of the questions that were raised. So some that I don't know, we could use as a starting point. We could either really start to discuss how to define what the product of our research should be concerning social robotics for education. Should it be the robot platform itself, a technical device, or the learning success, the learning progress of the students, as was pointed out. And the other one is how to facilitate. Another point that we could start is how to facilitate this shift towards a relational approach towards human-robot interaction. So these are things I think concerning the initial questions we posed, whether we have technical or theoretical limitations, could basically both go in this direction. So where we would need to start to improve our technological, or how we could do this, I find this digital twin idea very, very compelling from the technological perspective, and also this relational view is something that could be very interesting from a theoretical philosophical background perspective. So if I would give, I could give the stage to our panelists, and if you have questions or discussion points with each other, that would be great.
So maybe I can start if no one wants to start.
Please, please.
Okay, thank you. I really wanted to catch up with the idea of Hagen, that is this a technical or theoretical limitations that we have? From my perspective, from my experience and the work that we've been doing, I think I mean, there is part of like technical limitations, but I think the main limitation that we have is that we roboticists have the skills and the know-how to create robots, but we have no clue about what is a good educational program. And so what we're missing, and that's what we've been seeing with everything, like all the work that we've been doing, is that we cannot succeed in creating robots for education if we don't work with teachers and with people in education. And I think here, like David is really doing something amazing, doing this like programs for children, because this is really this, it's like bridging the gap between what we can do from the technological point of view and really taking it outside of our laboratories, of our like universities, and go to like, you know, younger like children with this. And without the technological tools to be able to enable end users to actually use the technology, there's no way we can see robots neither in education or in any other field, like the things that also Ioana was presenting, like robots in hospitals, robot in medical care. I mean, we're roboticists. We don't know what, like, how to care to like the people, but there are specialists doing that, and we need to like really empower them in using the technology if they want to do so.
Yeah.
So it's really working hand in hand with other people in like the field.
Yes.
I think from our panelists today, we have quite a nice overview of the parts. Unfortunately, yeah, I don't know if is Professor Rossi there, who is an expert in education.
Yes, I see Rossi in Professor Rossi in the panelist. In the meantime, I would say I want to say another aspect that okay, we have to think about the product, we have to think about teachers, but also I think that we have to start thinking in an holistic way to the entire system. So if we think about the research that is needed in this difficult system, I think that we have also to create a sort of large research lab, because we need of a lot of know-how, and probably today we do not have the right researcher to face this system, because we need to create a cooperative team that has inside a lot of know-how or knowledge that probably today we do not have. Because I don't know if Giuseppe is here, but we have to start thinking on a different approach for the new research in robots and in education, because up to now we used robots we use the human-like robot. We use biomimetic robot, and we use robots in every field. We use it in education. We use it in hospital. We use the robots everywhere. But I'm not sure that we designed the right researcher to create a robot for society, for education or for entertainment. If I can say, I don't know.
I think this is exactly.
Interdisciplinarity could be a key to this.
That's the research that I'm doing, and in particular with Ioana, with Luisa. That's exactly what we're doing, and I think it's the point also of Ioana's initiative, like robotics by design. So maybe Ioana, you want to catch up on this?
Yeah, I just want to say about this exactly. To put it in my words as a designer, so going from universal, because all these platforms of robotics that we use, we try to go from universal. These robots were not really designed for a purpose, except some of them, I mean, Paro or Roomba, okay, they are designed for a purpose. But these social robotics are designed for different things, and my difficulty is to make them specific. Here in this workshop, we talked about education. So this is, so I'm going to ask what is exactly like Gentiane, because I need constraints, I need a context. So what is it, what do you mean by robots for education? Is it about a robot who is inside a classroom? Is it one robot inside a school? Is it one robot with one person, with a child? So all this definition of where we place the agent, and I find myself in what you say about the ecosystemic, because also as a designer we are not dealing only one user, actually with its ecosystem of a person, the user, the grandma of the user, the father of the user, the friend of the user, because all of them are part of the interaction somehow, direct or indirect. So yes, for going to building from very specific field. So what does it mean to design for education? Sometimes maybe the answer is a robot, something that is intelligent, but sometimes it's not a robot, so it's okay. Sometimes it's human doing human job, so it's okay. So, but sometimes what Luisa is trying to do is explaining that robots have they could have something else. It's not to replace a teacher or a colleague. It could bring something else. For now, we try to figure out where the role. Okay.
Yeah.
Mm-hmm. Yes, I think also for this, basically the grounding in concerning education, the grounding in didactic theory is very important. To when you say you need limits for the design process, no, these limits need to come out of a theoretical grounding. So I
theoretical and practical. Look, we are in COVID, okay? We spend 1 year, more than 1 year now, we rethinking all our pedagogy in a design school. In a design school, we have to be together. We work in teams on projects. This is what we do from the first year to the last 5 years. We are always here. And now BEAM, everything is online. Mm-hmm. So this thing is happening. So we question ourselves, how do we want to educate our students? Are our students prepared for the world that this crisis is changing? And so we cannot, again, context situated action, always an action is inside a context.
Also, if I can say another point, you say COVID, and COVID, the pandemic in general, is a particular situation that, okay, we experience it day by day, but we have also to consider that our kid or our future citizen experienced the COVID as us. So during this year, we experimented a lot of tools that now are transparent for us. The Today platform or other platform like Microsoft or Cisco, just to give a number and names. So another point that we have to consider is that the future products or the future research results that we will have in the next year or in the next 10 years will have a bias. That the bias is that we are using virtual meet now. We change the way to design products because we are in virtual design in this year. Also research. Now we can say that we virtually doing some researches, and probably the future products or the future research results will have this bias because our lives are changing in this time. And I agree when Professor Damiano said that sociability is in the eyes of the user, but the eyes of the users probably now is very different of the eyes of the users of the last year. So we have also to reconsider what we said 2 years ago, probably, because now the society is not completely different, but more than similar than 2 years ago.
For me, the striking point of this pandemic is that for 10 years, the research I have done in social robotics was focusing on the role of embodiment, specifically in direct interaction. Now I find myself in a situation since 1 year where most of the interaction, the research we can do is virtual. So. Yeah. The questions now is, will people get used to this, or are they already getting used to this? Do they register the difference between a virtual agent and a robot with an embodiment they see on the screen? So I think this is also something that could be very interesting, and all the implications that come with it. No, like what role do social behaviors play in this kind of interaction? So I agree. It's a very interesting question, and a lot of it will depend on how long this situation will still be going on.
Yeah, I think it's also a very good occasion, this one, because we had a lot of discussion, at least in philosophy of embodiment, about the fact that the robots is embodied, but we were always referring to the presence. And I think that's something very interesting that showed the study, Hagen, you presented this morning, for example, or the experiments you are doing with Professor Rossi, teaching online with Pepper, is that anyhow, Pepper has a social presence that depends also online. And they can be perceived as a social partners by the students online.
Exactly.
And very effectively mediate the relationship between the professor and the students online. So we are learning a lot also about our social presence as humans, the social presence of an embodied agent like a Pepper, like a robot. So what is the social presence? Where is the social presence? What creates social presence?
Which comes back where we're making that it is a relational perspective, no? That it's neither in the person nor in the robot, in the
AI,
agent,
but in the interaction
between. Yeah.
And so what we are creating are forms of interaction. So what we are designing are, I think that the holistic approach you were describing was also implying this. What we are designing are interactions, are ecologies.
Yeah.
dynamical ecologies.
Yeah.
I think the problem is also how to body interact with learning. The problem is many times, in particular in educational robotics, people speak about the role of body, about motivation, about aspect not directly connected with learning. The problem is, I think, to rethinking the role of the body and analyze how to the body interact with the holistic process of learning. For example, in the morning we have a meeting and people speak about the role of a robot in coding, also in coding. And the role of in educational robotics, the body is only about secondary aspect. Is motivate the student, but not interact with holistic process of learning. And I think this is a problem, and we can analyze. And in this process is very important to work together with different approach, technology and educational expert. Because it's important also to modify, to rethinking also for us the role and the model of learning for understand the problem connected with the interaction human artificial agents.
Yeah, I think this also this comes back to the point of the interdisciplinarity of the field, no? That we really need to see different perspectives, that we have to bring together. Also, as Professor Scaradozzi said, that we kind of need to design the social robotics researcher for education, because it's not there yet. We are all coming from different directions, and we are trying our best to synthesize, to understand the other's perspective, intuitively understanding that all the different views are important, but as Ioana puts it, we need limits. These limits, I think, can be defined by the design of if you want a new form of research in this direction. I don't know if that makes sense, but
yeah.
Unfortunately, I think our time is already up. This is has been very, very interesting, and I think we could go on for another hour, basically, to have this discussion. So I don't know how to proceed from here. I took some notes about the major questions and points that were made. For me, the most maybe we can wrap up, and each of us says some take-home message from today. So for me, the most interesting part was the absolute necessity in working interdisciplinary and grounding our research also in theoretical approaches to didactics, and to rethink what our product should be, a robot, technical device, or actually should we focus on the learning success of the student and ignore by which means we achieve that. And then, yes, I found very interesting the focus on the actual interaction, on the relational term that was pointed out by Luisa, which is, I think, also very, very interesting. The creation of an ecology in which the agent can be integrated.
Mm-hmm. Maybe, Hagen, ecology of education, because the student is part of it, all the products, the classes, the school, all of them are part of it.
Teacher.
The teacher, of course, they are all part of it.
And the student changes whether it's a single student or whether we have a group of students, right?
Yeah.
So yeah, and where you place a robot into if it's something circular or different circles, where do you put this robot? Is it in between the teacher and the student, in between student and student? Is it a loop with the student? Some kind of, when you buy your notebooks for the year, you also buy a new software for your robot accompanying you the next year.
I think there are, like, on this aspect, there's really many questions to answer. Like, is the robot more a peer to the children? Like, for example, like the children play with it and ask questions to it, but it doesn't know more than them, or different, it knows things differently, but then the children also have to teach it. Like, if it were like a foreign or alien system that doesn't know anything about what's going on in their school or in their lives, or is the robot an equivalent to an adult with a lot of knowledge and a lot of experience, and then it has answers to many questions, and the children can, you know, refer to it to answer their questions. So there's definitely like many roles, and the robot doesn't, because it's a robot, doesn't have to stick to a very specific role. And I think like Luisa really make it clearly that this new form of social relationship where the robot is a different system. It's neither children, neither an adult, neither an animal, neither a human. And this is really making, I think, the research very interesting in this aspect. So, yeah, it's an
I think
exciting,
that
topic.
Yeah, I think that we have to start to talk about learning environments. So it's a sort of box where we have not teachers, not students, not robots, but agents in general. And each agent can teach, can talk, can learn, can listen. And the nature of the agents probably will give us the constraint or the limit of the agent himself, because, for example, the teacher also have to learn from the infrastructure what can obtain. Because if we think that we have a group of students, this means that we have a group of agents that can communicate something in the learning environment. And the same is the robot. If a robot can be the tools, can be the teacher, can be the student. So we have to talk about the robot agents that interact in the environment. So I think that we can conclude from my engineering point of view that we need to redefine the agents that interact in this sort of general box that we can call learning environment.
And I find it very interesting, all the connection between these different views. And so the idea that at the end, what we have to try to design are emergencies, emergent relationship that we cannot foresee a priori completely. So yes, an ecology, we have to structure an ecology and co-evolve with this ecology, also as designers, so as professors, students.
One of the, I don't know, one last question I would like to pose is, what do you think? Would we need a specifically dedicated, designed robotic platform that is widely used for educational purposes? As we pointed out, as Ioana pointed out, at the moment we are using, I used now Pepper, specifically Pepper is not necessarily designed for educational purposes, but more for, it's also used in banks and in entertainment in malls and stuff. So would it be necessary to have a robot that has a specific task to be put in a classroom?
Hagen, I think that we learn a lot from all these robots. I think that we learn stuff, and for me, I usually say they are a pretext. They are probes, cultural probes that will tell us something. They are not the final thing that we will use in this environment. I really like this idea of ecology environment where things are not fixed, roles are not well determined, where because it's a very beautiful way of what means learning. It's a very freedom way. I like it a lot. But I think that we still learn, we can learn, but not, again, be stuck with a form. Use it as a platform for us to develop what we mean when we talk about mediation in education, okay? What could mean the need of social agent in education. So until this researcher is going to design something from the field, specific to the field, with the need of the field, we can use what is there to understand things, I think.
Yes, I think that we can go back at the time industries designed the plug and play. All of us has the plug and play inside our operative system, and we have different operative system, but the plug and play is the middleware that recognize the capacities of the board, the electronic device that we put inside our notebook or our personal computer. So what I want to say is that we need to develop the plug and play, and I think that here the plug and play is a theoretical description of what we need from the environment and what we need to recognize in the agents to say that agent is able to be used for education or for edutainment. So I think that we have to start talking about capacity, ability, intelligence, cognitive, etc., in design the levels before say this technology or this other technology, because I suppose that we do not know what is what are the technologies that we need to this point.
Yeah, it also strikes me that at the moment we have a very exploratory approach to a lot of things.
Serendipity, no?
Yes. Well, it's I think Luisa, would you like to say something about this as well?
No, I totally agree, and agree also on the, and I would like to underline also that when we think to a robot as a social agent, we have to leave it open, or it's impossible to close. In a sense, too much. So I agree on this. That's why I was talking about the design of emergence, something that you cannot control completely. You have to co-evolve with.
Okay, so yes, now unfortunately we're already 10 minutes over time. So I thank everyone, specifically the panelists. I thank you very much for attending, for sharing your thoughts and interesting research. And I hope that we can maybe work in the future together on some projects or some ideas that we formulated today. So thank you very much for your time. Thank you very much for your dedication and for your presentations. It was very great to have you. Thank you very much.
Thank you.
Thank you. Thank you. Bye.
Bye-bye to everybody.
Bye.
Bye.
And thanks for the attendees.
Bye-bye.
Thank you. Bye-bye.
Bye, Gentiane. Bye-bye.
You.